Section 3.4.14, a manufacturer of bolts has a quality control policy that requires it to destroy any bolts that are more than 3 standard deviations from the mean. The quality control engineer knows that the bolts coming off the assembly line have mean length of 11 centimeters with a standard deviation of 0.2 centimeters. For what lengths will a bolt be destroyed? So for number 1, we first determine an inequality or set of inequalities that represent the length of a bolt that will be destroyed, where z is the z-score of the length of the bolt. The set of inequalities shown below represent lengths that exceed 3 standard deviations from the mean. Since it's 3 standard deviations, you can see that we have z less than -3 or z is greater than 3. Now, the next thing we want to do is we want to look at what our formula is for the z-score. So z is going to equal x minus the population mean divided by the standard deviation. Now, what do we know from the given information? Well, we do know that the mean is 11 centimeters, so we know that the population mean is 11. We know that the standard deviation is 0.20. So this is what our formula would look like. Z is equal to x minus 11 over 0.20. Now, we do have a value of z. One of them is -3, where z is less than -3, and the other one is z is greater than 3. So we're going to use that information to determine the range of values that will result in a bolt being destroyed. We're going to substitute the formula for the z-score into the previously determined set of inequalities and solve for x. So the first one that we have up here, z is less than -3. What we're going to do now is take this part of our z-score formula, x minus 11 over 0.20, and we're going to set that to be less than -3. And the reason why we're doing this is so that we can find out what does x have to be, or what range of values will x have to be in order for it to satisfy this inequality. So the first thing we're going to do is, in order to isolate x, we're going to multiply both sides of the inequality by the denominator, which is 0.20. So what happens is now we can simplify the 0.20 and the 0.20, and we're left with x minus 11 on this side of the equation, on the left side. On the right side, we have -3 times 0.20. And then in order to isolate x, we're going to add 11 to both sides. So x is going to be less than -3 times 0.20 plus 11, which gives us 10.4. So x has to be less than 10.4. Now over here, for step number 5, okay, we are now using the fact that the inequality over here, z, is greater than 3. So now we're going to take what we have for z and replace it with x minus 11 over 0.20 and have that be greater than 3. So we're going to follow the same procedure that we did on the left side. So we're going to multiply both sides by 0.20. We can eliminate the 0.20, and what we end up with is x minus 11, which is greater than 3 times 0.20. And then in order to isolate x, we're going to add 11 both sides to the inequality. So we get x, which is greater than 3 times 0.20 plus 11. So therefore, x has to be greater than 11.6. So what that means is a bolt will be destroyed if the length is less than 10.4, or we have our or statement, or greater than 11.6 centimeters.